In this lesson, we are going to look at ideal gases and what are the assumptions that we have to make when we consider learning about the property of gases. And the only way we can actually determine the calculation is that we assume that the gas is ideal. Now, before we look at the assumption, we have to look at the two situations that's best for ideal gases. And that is the molecules are small. They are very small. And how do we know the molecule is small? We can look at the molar mass of the molecules. So in some question, we'll ask you which of the gases will be best considered for ideal gases. You have to look at the molar mass of those gases. Another factor that we look at is the pressure. The lower the pressure, the more ideal it is going to be. Now, the last component it is the temperature. The higher the temperature, which is the higher the average kinetic energy for that particular sample of gases, is more ideal. So ideal gases is best for smaller molecules, exist at lower pressure, but at higher temperature. Now, let's look at the specific assumption. First of all, the greater the temperature, the greater the average kinetic energy. Another assumption that we are going to look at is that different gases exist at the given temperature, that is, exist at the same temperature for this different sample of gases. All the gases have the same average kinetic energy. So different sample of gases at the same temperature have the same average kinetic energy. Another assumption that we have to make for ideal gas is that the volume of the gas is insignificant. That means it doesn't count. It doesn't have an impact on the properties of gases, okay? So the volume of ideal gases are insignificant. It does not matter. Another important assumption that we have to make is that there are no forces of attraction. There are no intermolecular force between the gas molecules, okay? So the molecules, in this case, they don't stick together. They don't attract together. And lastly, the gas molecules are in constant motion. That means they are constantly moving in a constant motion. And that is, when they collide with one another or against the wall, they are not losing any energy. So there are no energy being lost when the molecules are collide with each other or when the molecules collide against the wall of the container. So these are the assumptions that we make for ideal gases. And again, ideal gases are best described gaseous molecules that are very small at a very low pressure, very high temperature. And as always, these are very important facts that you have to remember when we solve problems, especially multiple choices question. You have to apply one fact at a time in order to determine the correct answer. And as always, if you have any question, take a picture of your work, put it in the forum, and tell us what you have learned so far, and then we will help you from there. And we see you next time on another exciting chemistry lesson.